Sorry, my video cut in the previous one, so I'm actually going to continue so that you can see. So like I was saying in my previous video, you notice in this case that the number of nitrogen atoms is equal to the number of atoms of nitrogen on the left hand side. So our focus is going to be on what we are calling as being magnesium. So there are 3 magnesium. So what number should you put in front? Remember, when you're balancing, you only put coefficients. You only put coefficients or numbers in front of a formula that you have. So since there are 3 magnesiums on the right hand side, I will put up a 3 in front of magnesium. It simply means that there will be how many magnesium? There will be 3 magnesium. So this will cancel. I'll now have 3 magnesium. It simply means that the equation is what? The equation is actually balanced. So it's not complicated. It's something that is actually easy that you can actually deal with. Let's try to look at another one. In this case, you have got phosphorus reacting with oxygen to produce what we are calling as being we are talking about phosphorus 5 oxide. So that is what we mean. So this is what you're having there. So let's try to see if you're able to balance. You can still pause the video and try to see if you're actually able to balance up. So remember, on the left hand side and on the right hand side. So what are the atoms that we have? We have phosphorus and oxygen. Then on the right hand side again, phosphorus and oxygen. So that is what we have. So how many atoms of phosphorus do we have on the left hand side? You only have 1, and of oxygen we have 2. Remember, there's a 1, but 1 times 2 gives you a 2 there. What about for phosphorus? Of course, it is simply, there's a 1 there. 1 times 2 is just a 2. Again, 1 times 5 will just give you a 5. So these are the number of atoms that we have on the left hand side and the right hand side. So we need to balance up this equation because the equation is actually not balanced. You can see they have got different atoms, they are not balanced. So how do we balance up in this case? Well, remember, when we are balancing up, we only put up whole numbers in front of the formula. We don't change the subscript. Those do not change if they have been written like that in the formula. So what are we going to do? So basically what I can do, because I've got 5 oxygen atoms and 2 there, I can actually put up a 2 in front of the phosphorus 5 oxide. So when I put up a 2 in this case, it simply means that, remember, oxygen this side has a 2, so you can use that. Balancing is actually about trial and error. So when I put up a 2 there, it will be 2 times 5, which will now go to 10. But the moment oxygen becomes 10 on the right hand side, it simply means that because of this coefficient 2 you have added, you have changed the phosphorus. It will be 2 times 2. The phosphorus will now go to 4. So therefore, let's try to balance up on the left hand side. On the right hand side, there are 10 oxygen atoms. So what number should I put in front which multiplies by this 2 that is already there so that I can have a 10? You know, of course, that is a 5. So 5 times 2, it will now go to 10. How many phosphorus on the right hand side? You had 4. So what number should you put in front there? Remember, there's a 1 there, so you need just to put up a 4. 4 times 1 that you cannot see there, that is actually going to give you a 4. So if you notice, 4, 4, 10, 10, it simply means that the equation is what? The equation is balanced. Well, let's try to look at some more equations and see if you are able to actually, balance, if you are able to actually balance them. Suppose I gave you in this case that iron is reacting with oxygen to produce what we are calling as being iron 3 oxide. Go ahead, you can pause the video and try to balance it up. In this case, we'll look at the number of atoms on the left hand side and also on the right hand side. So if I look at, I've got iron and I've got oxygen, and I also have iron and I do have oxygen this side. So on the left hand side, how many iron are there? Of course, we only have 1. What about oxygen? There are 2. What about iron on the right hand side? 2. What about oxygen? It is simply 3. So you can see the number of atoms on the left hand side is not the same as on the right hand side. So therefore you need to actually balance up this equation. So how do we balance up that very important aspect that we need to look at? So in order for us to balance up that, what I can simply do is that if I look at, there are two atoms of iron, so I can likely put up a 2 there, but even if I put up a 2 there, the number of oxygen atoms will not balance. But what I can do, because of these 2, I can try to interchange and say, suppose I put up a 2 in front of the iron 3 oxide. It will be 2 times this subscript here 3, so 2 times 3 will give me, in this case, 6. So this number will go to 6, and if I look at the iron, it will be 2 times 2, so this number will now go to 4. So what number should you put in front here of the oxygen so that you can have 6? Remember, you can balance up 3 with a 2 and 2 with a 3, so I'll put up a 3 there. So it will be 3 times 2. It simply means the oxygen will go to 6. What about the iron? On the right hand side it is 4. What number should you put in front of the iron so that it can become 4? You are right, you need a 4 there. So you can see this will now change to 4. If you look at the atoms on the left hand side and the right hand side, they are balanced. So it simply means that the equation is what? The equation is actually balanced. That is what we mean. Okay, let's try to see, for some of you that want something that is more challenging. Let's say that sulfur is reacting with fluorine to produce what we are calling as being sulfur hexafluoride. So it produces sulfur hexafluoride. Go ahead, you can pause the video and try to see if you are able to to balance up this one. So sulfur hexafluoride, of course, on the left hand side, and atoms on the right hand side. So I've got sulfur and I've got fluorine. I've got sulfur and I've got fluorine. So those are the atoms that we do have. So on the left hand side, how many atoms of sulfur do you have? You're right, that is 8. What about fluorine? You have actually 2. What about on the right hand side? Remember, there's a 1 here, even in front. 1 times 1, it will still give you a 1. Here there's a 1 here which we don't write. 1 times 6, it will give you just a 6. So is this equation balanced? The answer is no. It is actually not balanced. So let's try to see if we are able to balance it to balance it up. That's what we mean. So now if I look at this one here, if you look at it, suppose since there are 8 sulfur on the left hand side and there's only 1, suppose I was to put up, in this case, 8 there. Remember, it's just a try and error. You try out. Suppose I was to put up 8 there. What is that going to give me? So that's the idea that you need to have. All right, so now it simply means the sulfur there will also become 8, but the fluorine is actually going to become affected. It will be 8 multiplied by 6. What is 8 multiplied by 6? It will give you 48. Of course, if it gives you 48, it simply means fluorine will now become 48. But what number should you put in front when you multiply by 2? It will give you a 48, so that on the left hand side it can also be balanced. Are you thinking of a number? Yes, you can actually put up a 24. 24 times 2 will simply give you 48. It simply means that this equation is what is actually balanced. For some of you that requires something that is actually maybe more challenging, let's try to look at this reaction where you have got a hydrocarbon. You actually have a hydrocarbon, propene, burning in oxygen. So it actually burns in oxygen. So it burns in oxygen to produce carbon dioxide and H2O, carbon dioxide and H2O. So that's the idea. So if that is the equation, I hope you are able to see that. So mainly when you are dealing with an hydrocarbon, this reaction is what we call as being a combustion. This is what we call as being a combustion reaction. So for any combustion reaction that you have, let's look at the left hand side and also the right hand side. So in this case, I've got carbon, I've got hydrogen, and I've got oxygen. All right. Then again on the right hand side, you are going to have the same elements that are going to be there. Please remember, there's actually oxygen that is actually there. So if you look at this one, when you're balancing a hydrocarbon, it is always best to start with, first of all, you balance up in this case the carbon, then you go to the hydrogen, and then lastly you balance up the oxygen. That's the order in which you can actually balance. Very important. So for example, let's identify the number of atoms that we have. How many carbons are there? We have 3. How many hydrogens? There are 8. And how many oxygen? There are 2. Then of course on the right hand side, how many carbons are there? You can see there's a 1. How many hydrogens are there? You can see a 2. How many oxygen? You can see here there's a 2, but it says plus here there's a 1. So 2 plus the 1 that is there. So that actually gives you a 3. So basically, if you try to look at this equation, you can see that it is actually not balanced because the number of atoms on the left hand side is not equal to that on the right hand side. So what do we need to do? Well, we need to balance it up. Like I told you, when you're balancing an hydrocarbon, always start with the carbon. So because on the left side you have got 3 carbons, so what number can I put up there? Yes, you can actually put up a 3. Is it okay? So carbon is actually balanced. It simply means that you have got 3 carbon atoms on the right hand side. Then the next thing, you go to balance up the hydrogen atoms. Here you have 8. What number should you put in front of the water so that you can have actually 8? Of course, that is a 4. So you need to put up there a 4. 4 times 2, it simply means the hydrogens will go to 8. So once you balance up the carbon and you balance up the hydrogen, you can now balance up the oxygen. So what you do, you start with counting the number of oxygen on the right hand side. So here, if I look at it, is 3 times 2, there's 6 oxygen there. Then if I look at that, it is 4. Remember at the bottom there's a 1 which you can't see. 4 times 1 will give you 4. So if you add here, there's a plus sign. So 4 plus 6 plus 4, that gives you 10. So meaning the total number of oxygen on the right hand side has now come to at 10. So now once you balance up that, you can ask yourself, what number do you need to put in front when you multiply by this 2, the subscript 2, you have 10. Yes, you are right. It's a 5. So it's just 5 times 2, and that will give you 10. So you can see the number of atoms on the left hand side is equal to the number of atoms on the right hand side. It simply means the equation is balanced. Okay, so I'm going to leave with you the last question there under hydrocarbon and see if you are able to balance it up. This is also an hydrocarbon butane, in this case C4H10, reacting with oxygen to produce carbon dioxide plus H2O. Please, I want you to pay attention and actually look at this one. So look at the left hand side and also the right hand side. Okay, so now when you look at this one, in this case, you're going to find that we have got carbon, hydrogen, and oxygen. So carbon, hydrogen, and oxygen. So that is what we have there. So let's identify the number of atoms. So for carbon, there are how many? Of course, I have 4. Carbon 4. For hydrogen, there are 10. Oxygen 2 on the left hand side. What about on the right hand side? Carbon 1, oxygen, it's 2 plus the 1 that is there, so it is 3. But for hydrogen, it is 2. So you can see that this equation is not balanced. So we need to balance. Remember what I told you, when you're dealing with an hydrocarbon is a substance consisting of carbon and hydrogen atoms only. That's what we call as being. So this guy here is simply an hydrocarbon. burning in excess oxygen. This is called combustion, and when it burns in excess oxygen, it produces carbon dioxide and water. So let's start by balancing. Like I said, carbon, you go to hydrogen, the last should be oxygen in this case. So what am I going to start with? You balance up the carbon. So since there are 4, what number should I put there? I need to put up a 4. So 4 times that, it simply means the number of carbon will also become 4 on the right hand side. The next thing, you go to balance up the hydrogen. Here I've got 10 on the left hand side. So what number should I put in front of the water so that I can again have 10? It simply means you can actually put up a 5. 5 times 2, it simply means that will go to 10. Now the moment, remember, you put up a 5 there, that oxygen becomes affected. So for oxygen, it will be 5 times the one that you can't see there, which we don't write, and that will simply be a 5. Here we have 4 times 2, it will be 8, but there's a plus, so 8 plus 5, that will give you 13. So here on the right hand side, you have got 13 oxygen atoms. So how do you balance up there? Is there any number that you can put up, multiply by 2, that will also give you 13? So you write it as 13 over 2, because you just need 13 in this case. So you write 13 over 2. Remember, when you have 13 over 2, multiply by this 2 that is there, multiply by that 2, this 2 and that 2 will cancel. You remain with just 13. But when you are balancing, you do not want fractions in as coefficient. So you get rid of the fractions as coefficients. So what do you do? So what you simply do is that you multiply the whole of this by this number here, the denominator that you have, which is a 2. So I'm going to actually multiply throughout by 2 so that I can see what will be the new coefficients that I'm going to have. So it will be 2 times that, so it will give me 2 C4H10 plus 2 times 13 over 2. This will cancel, it will just be 13O2, and it will be 2 times 4 will give me 8CO2 plus 2 times 5 will give me 10H2O. So you can see what exactly you're having. So these are the new coefficients that balances the equation. We have gotten rid of any fractions that were there. So this is the way you can actually go about it. Please watch out for for some more videos. In case you missed out on writing for chemical formulas, you can actually try to rewatch videos on that. If you like, you can actually hit that like button, or you can subscribe and see more videos as they come. Thank you so much for watching. Watch out for more videos.